Now very most important next topic is plane of symmetry. What is plane of symmetry? Plane of symmetry, it is a imaginary plane passing through a molecule which can bisect the molecule into two equal of and both of are mirror images of each other. Such plane is called positional plane of symmetry. Plane of symmetry. Once again, student, what is the plane of symmetry? It is a imaginary plane passing through a molecule which can bisect the molecule into two equal of and both of are mirror image of each other, mirror images to each other. Such plane is called plane of symmetry. POS is called, POS means plane of symmetry. What is plane of symmetry? Once again, it is a imaginary plane passing through a molecule which can bisect the molecule into two equal of, cutting with, simple, bisect means cutting with two equal of, into two equal of. This both of our molecules are images, both of are mirror images of each other. Such plane is called plane of symmetry. Now take the, what is the bisect the molecule means cutting with two of. For example, now take the cyclopropane example. Here this cyclopropane having two chlorines are there. These two chlorines present in front side. So cutting with here, this is middle of the center point. Cutting with here, here left side is half equal, right side half equal, both are half of molecule. These half of molecules are mirror images to each other. This mirror to this one, and left side compound mirror image to right side compound, mirror image to left side. So both are mirror images of part same type. So this is the mirror images. So that is also plane of symmetry. It is a imaginary plane pass through a molecule which can bisect the molecule, means cutting with two of molecule. So to 50% one of, 50% of another of. So 50% is mirror images to another 50%. This is called plane of symmetry. Now take the another example now here, and what is this one? The cis 2 butene. Now take the cis 2 butene. Here now take the cutting with here in vertical, cut with half of part, cutting bisect means cutting with half of, slice cutting with here. So here half part left side one methyl group is there, one hydrogen is there. Half part right side one methyl group is there, one hydrogen is there. Both are equal of. These equal offs are both are mirror images each to both are mirror images of each other. Such plane is called plane of symmetry. This it is cutting with half of part. This left side of equal, right side of both are equal. So these both are mirror images. So it is also this compound also contain plane of symmetry. This plane of symmetry compound optically inactive. Once again, so this is compound is optically inactive compound, optically inactive. It is very most important, student. And this compound also optically inactive. Why? Because of this molecule contain plane of symmetry. If plane of compound contain plane of symmetry is there, if molecule contain plane of symmetry, that compound is always optically inactive. Compound. These both are optically inactive, both are plane of symmetry. So that's why these are the both are optically inactive. Now take the another compound. Now here 1 2 3 4 carbons are there. He cutting with two of equal, cutting with two of molecule, cut with half here, cut with here. So here left side two carbons are there, right side two carbons are there. So this left side here one chlorine is there, one bromine is there. Chlorine present an upperwards and bromine present lowerwards. So these both are here, both right side chlorines are. So the left side carbon also chlorine bromine is there, right side carbon also chlorine, but these both are equal to each other. These both are the mirror images. These both are mirror images. So these also contain plane of, this molecule also contain plane of symmetry. This molecule also plane of symmetry. Why? Because of this both are equal of one of both are the two into two equal of, and both are the mirror images. So that's why it is the plane of symmetry. This is also optically inactive. This compound also will show optically inactive. And what about this compound? This compound having same one CH3 group is there. So now here take the horizontal line, cutting with horizontal plane, here both are half of molecules are there, and upperwards CH3 and COH and H, lowerwards CH3 and COH, like that same thing. So it's both are in cutting with horizontal line. cutting with horizontal plane. So here above the plane and below the plane, above the plane same molecule and below the plane same molecule. So is both are mirror images, both are mirror images. So that's why it is also optically inactive, and this molecule contain plane of symmetry. This molecule also exhibits plane of symmetry. This molecule also plane of symmetry. So plane of symmetry molecule is always optically inactive. Optically inactive. So it is also very most important. These compounds are cutting with vertical line. This compound is cutting with horizontal line. So above the plane and below the plane, both are the mirror images to each other. So that's why it is the plane of symmetry compound, plane of symmetry molecule. Next, another one is, now take the another example. Tartaric acid is there. Here COH group is left side, hydrogen is there, OH is there, left side hydrogen is there, and OH is there, downwards COH group. So this is the tartaric acid. Cutting with here also horizontal plane, cut with horizontal plane, slice with horizontal plane. So above the plane and below the plane, both are the equal. Above the plane COH group is there, hydrogen is there, right side OH group is there, and below the plane hydrogen is there, right side OH is there, COH group is there. So these both are mirror images. So these both are mirror images to each other. So that's why it is also, this compound also contain plane of symmetry. This compound also plane of symmetry. Plane of symmetry molecule always optically, plane of symmetry molecule is always optically inactive. Optically inactive. This is also important, student. So this tartaric also, because of two chiral centers are there. These two chiral centers are there. That is also, all chiral centers are not optically activity compound. So these more than one chiral centers are there. That is optically inactive compound, optically inactive, not 100%. Both active or inactive, both optically active or some compound optically inactive also. Only one chiral center is there, that is always optically active compound. That is very most important, student. Compound contain only one chiral center, only one chiral center is there, that is always optically active. More than one chiral centers are there, that is chiral centers are there, that is maybe optical or optically inactive or optically active. That is very most important, student. Now take the another example. Now here this this compound and this compound also same, cutting with two of here vertical plane, cutting with two vertical plane. So here left side this compound, this carbon having CH3 and downwards hydrogen, right side CH3 and left side downwards hydrogen is there. These both are equal of, cutting with a vertical line, cutting with vertical line. So this is the plane of symmetry. So both are mirror images to each other. This part CH3H and right side also, these both are the mirror images to each other. So that's why it is also plane of symmetry. The compound contain plane of symmetry. And another thing, it is compound do not exhibit optical isomerism. So it exhibits only its compound is optically inactive compound. This compound is optically inactive compound. So this is the very most important, student, plane of symmetry. Compound contain plane of symmetry and center of symmetry is there. That compound is always optically inactive. That is very most important, student. So compound contain plane of symmetry and center of symmetry is there. That is always optically inactive compound. But compound does not contain, if compound does not contain plane of symmetry and center of symmetry, that is always optically active. What is the condition for optically active condition? Compound does not contain plane of symmetry and center of symmetry, both are absent, that compound is always optically active. In the presence of plane of symmetry, compound contain plane of symmetry and center of symmetry is there, that compound is always optically inactive. This is very most important, student. If you like my video, please like and share, and thank you. Please do subscribe my channel. Please do subscribe my channel. Once again, thank you, students.